All right, what's up, GAC and YouTube followers? This is Coach Johnson, and right now we're going to go right straight into law of sines, cosines, and vectors. Again, we're live in a class right now, so we're going to have questions that will be asked throughout the course of this time, and then we'll answer those off of our review sheet. So hopefully this helps, and let's go. All right, so what we're going to do here, as I pull this up, we're going to start on a couple of problems that some students struggled on, specifically off of our review sheet. I think the first one we're going to go over is number 5. Okay, we're going to go over number 5. That one is involving an angle side-side triangle. And then after that, if y'all could just remind me, at the end, we're going to give some questions that will be over the test that weren't on the review sheet. Okay? So let's get this show on the road. I think, let me see.
Oh, watch the base.
All right, sorry about that. Trying to plug in the, where is it? Where are you?
It's right there. You said
We're all over it.
You're only over.
All right, my bad there. All right, so number 5 is one where we're talking about angle side-side type of triangle. So in this one specifically, we are given that within our triangle, now actually let's change colors here so we can see, that within this triangle we have 16, and we know that the angle A is always across from my side A. So we know that. We also know that if B equals 18, we'll put that in, and where the angle B is across from side B. And then obviously we have angle C, and then we are good to go. Now, we do know that angle A is equal to 60 degrees. Now, when I read this, the big thing that when I approach this problem is anytime that I have two angles, I know that I'm going to be using my chart, and I'm going to probably use the law of sines. In fact, I know I will. So with two angles, we're going to use law of sines. We'll find the third angle and then approach that by finding the missing side lengths. Now, here's where the struggle comes. Some of you may not have that sheet right there, but you will have it for the test. I was meaning to give it to you today, but just didn't get around to it. So as you leave, if you need to take a picture of that, you can. Again, you can use that on the test, and I will give that to you come the test day. All right? So if we know that it's angle side-side, notice the difference between this and a triangle where I have this angle, this side, and this side. Right? So that's a little bit different. This is side angle side. And for this one, I would use the law of cosines, whereas on top here, I'm going to use a law of sines. Now, if I have angle side-side, right, I know that in this case, I'm going to go right straight to the law of sines. So if I were to set that up, someone want to take kind of leadership on that? What would I do to set up this triangle here to solve for my missing angles and missing side?
60 over 16.
Bingo. Yeah, so let's go sine of 60 over 16 equals the sine of B over 18. So right there where we're setting it up. We also know with angle side-side, we've got to be able to also have a chart where we have two possibilities for angles. Now, if we had no triangle, that means that I'm going to have an error back to me. And then also whether it's one or two triangles depends on how my chart ends up being filled out here. Okay? So now at this point, when I cross multiply and divide, I'll have 18 sine of 60 equals 16 sine of B. Now, if I divide by 16, divide by 16, 18 sine of 60 divided by 16 equals what? Someone want to throw it down? What would you get there? Would you say?
77.
77. Good. So if I did that now, 77 would be my degrees for angle B. And since I know angle A is 60 degrees, what I can do is actually plug 60 degrees in for angle A for both parts there. Now, if this one's 77 degrees, we know that there's 3 different locations where it will add up to be equal to 180. We have our traditional 2 triangles right here. Those will have to add up to be equal to 180. And then also, I know that within my angle B, that since that's the first one I solved for, that has to add to be equal to 180 as well. All right, so we know that. Now, if this one's 77, we'll subtract that from 180 to get my second triangle, which I got 103. So since I've got 103, I'll put that in, and I'll keep that right there. Now, on the two triangles, I've got 60 and 77. I could subtract it from 180 to get what from my third angle? Is it 43? So thank you, Anna. Appreciate that. So we have 43 degrees there. And then for my second triangle, 60 plus 103, subtracted from 180 gets me, 17. So because I could find an actual angle here, that's why I have two triangles. If I could not get this 17 because this would exceed 180, I know I would cross that out, leaving me just one possible triangle available. You'll notice that on number, what number is that? Number 3. That's a good example of where you would do this process and only get one triangle out for number 3. Okay? A lot of you on the review game would do this and only get one triangle, and I said, hey, you have to go back. You have to make sure you have 2. So just be careful of that, but that would be my process there to find those angles going forward. All right? Does anyone have a question on how I would approach this one? Is this ringing a bell? Is this the only one where you could possibly have 2 triangles?
Yes, because
Correct. So this is the only one, side angle or angle side is the only one where you could possibly have 2 triangles. So this is the only case where I could possibly have that there. Okay? Everyone good? All right. Does anyone need me to go over how to find side C? Because we've got the angles, all we would do now is the law of sines. Traditionally, defined with 43 and 17 degrees, you'll have 2 possible side lengths of C. All right. Right on. All right, make sure we're still up here. Make sure you're still with me. I want to make sure we go through it.
So because we have 2 possible side lengths, 2 equations.
Correct. So if I were to do it, I could just say sine of 60, which is my A, over little a, which is 16, equals sine of 43 over, since it's C right here, right? We'll have to put little c down below. So that would be part 1. And part 2, I would do the same thing. The only difference is I would put sine of 17 over C so that I could find 2 possible side lengths of C for that triangle. Okay? All right, right on. Is there another one that you need me to go over at all?
Can you do one where there's 2 sides and one like a law of cosine?
Oh, law of cosines one? Like number 6 maybe?
Yeah.
Number 6 a good one? All right, let's do it.
Wait, we do one like number 7 too.
Yeah, we could do number 6 and 7 we could go into. Yeah, absolutely. All right. So, and again, if you get this, by all means, go on to another one. All right. All right. Go on to another one. Keep going there. Get this review sheet done. So all you have to do is review. So number 6 says this: side length A is equal to 7. C is equal to 3, and angle B is 90. Well, if this is little a, this would be big A. This would be big C, and we know this one would be my big angle B there. All right, so we know that it's in this one, if B is 90 degrees, we have a side angle side. All right, do you see that there? Side angle side. So since we have side angle side, it's different than angle side side. Remember, angle side would be sines, where side angle side would be cosines. Okay, Mike, did you say something there?
Cursed.
Say that again.
You cursed.
I'm cursed.
You cursed.
I'm lost. Oh, okay. I got you. I was like, oh yeah. I see. How about we put dashes in between? There we go. ASS, not yeah. Very good. So now in this case, we're going to end up solving for our missing length. Now, if I know what A and C are, what I can do. Yeah, that would be good. If you could guess that laugh on this podcast, tell me and I'll get you something. I don't know.
You can pay me for guessing my laugh.
Let's know that both angles are 45 degrees.
You don't know that because you don't.
Oh. Okay.
You know what I mean? They could be any different thing. Okay? So now we have b squared equals a squared plus c squared. The reason why we're using b squared is because that's the angle that was given. I was given 90 degrees, therefore, that's why we're solving for what our side length b is. So b squared equals a squared plus c squared minus 2ac cosine of big B. Okay? So now if I plug in, a is 7, so we have 7 squared plus 3 squared minus 2 times a, which is 7, c, which is 3, and cosine of 90 degrees. Okay, so we're going to plug that in. So b squared equals 49 plus 9 minus, and then we're just simplifying. So 14 times 3 would get, 42, cosine of 90. So as I solve this, you'll notice that a lot of people will do the following. This is what not to do. You may, go ahead. What a lot of people do with this is they'll end up trying to subtract 58 minus 42 and try to get something out, when that in actuality, that's incorrect. What do you need to do first?
42 cosine 90 first.
Exactly, 42 cosine 90 first. Once I do that, is it 0? Thank you, Emily. So now we got 58 minus 0, which gets me just 58. And what would we do that after that? We would square root. Very good. So when we square root, we get b is equal to root 58, which in a decimal we'll do.
7.6.
You said what again? I'm sorry.
7.62.
7.62. Good. And you could do it to the tenths if you'd like to, hundredths. I won't take off. Either one of those is fine. So if it's 7.62, my next question is how would I find what angle A or C is? Law of sines, right? So you could just do sine of 90 over 7.62 because it's the angle over the side length equals sine of A over 7. Because again, A over 7 is, and we're trying to solve for what angle A is there. Okay? Morgan, does that make sense? Does that help a little bit? Sweet. Any questions on this one? All right. B, you said number 7. Let's do it. All right. Number 7 is one where we have all 3 side lengths. Now, here's the question, and this is where you really got to look at your sheet, because I kind of messed up how I had talked about this, and that's partially my fault here. Which side length are you going to solve for first? The longest first. Now, that's different from what I said with law of cosines. It's on your sheet that I'll give to you, so you'll have that, but it's always the longest side. Alex?
Why does it matter which one you solve?
Because if you solve for the smaller side, what happens is it'll give you a different answer. The way that you end up using, question here, what would you end up doing to solve for the angle? Well, you'll be doing an inverse of some kind, right? With the inverse, remember, it's got to be within our range. So within our range, sometimes it'll end up determining or getting out an answer that's different. Sometimes if you end up solving for the smaller side first. A lot of times you'll see this a lot in obtuse triangles. So that's where it's really impacted in that way. So because we don't know, we do it every time the same way, just in case. Okay? So that's why we'll put c squared first. So in this one, we'll have c squared equals a squared plus b squared minus 2ab cosine of c. So let's plug in. 9 squared would be 81. A squared is 16. B squared is 36 minus 2. A times b would be 36 here. And then cosine of big C. So now we're just solving. 16 and 36 make 52 minus 72. Cosine of C equals 81. Now here's where a lot of you messed up. Okay, when you ended up checking with me and I told you it was incorrect, here's where you messed up. A lot of you subtract right there. Okay? It's incorrect. Can't subtract there. What do we need to do first?
You can move the numbers onto the other side.
Good. Take 52 to the other side, right? So 52, subtract. So 81 minus 52 gets me 29, right? Okay, so 29 equals negative 72 cosine of C. So let's divide by negative 72. Divide by negative 72. So what does cosine of C equal?
Cosine. They do the inverse of cosine, whatever the answer that is.
Bingo. And this is where we were, Alex, right? So we got to do the inverse cosine of that, like B said. So when we do that, cosine inverse of both sides, I'll get C by itself. So angle C equals cosine inverse of negative 29 over 72. And I think when you did that, what'd you get out for angle C? 114. Awesome. And we could round it to the nearest integer here. So 114 degrees is perfect. How can I solve for my second and third angle? Exactly. Let's do law of sines again to find what those other two angles are there. Okay, Anna?
How would you get? I did not get 36.
Okay, you didn't get 36. Did you do 6 squared? You get 30. That's where I got this right here, right? So B squared would be 6 squared, right? To get 36.
No, for
For the 2 over
36
36,
on
I got 48 when I did 2 times 8 times 8.
Yeah.
I got 48.
Ah, that's wrong, right?
4 times 6.
That's right. Yeah. So 2 times 4 times 6. Thank you, Anna. Appreciate that. Thank you, Eric. Drew, appreciate it. So 4 times 6 is 24, right? That's why I'd messed up. I'd looked at it and did 4 times 9, and so I didn't do it right. So that's why you don't skip steps, right? It's true. So right here, this should be 48, right?
Yeah.
So then once I subtract 52, I'm going to divide by negative 48, and that's where this should be here. Again, same idea. I'm guessing, Alex, we still would get 114, or did I?
I got 127.
127? Excellent. Excellent. 127 degrees, and that was my fault there. 127 degrees. Yep. 127. All right. What do you think? We good? Are we good on these?
Use sines from there.
Yeah, then we just do the law of sines from there. And again, to find those other two angles, we could take it and then go from there. Okay? All right. So what do you think on the first page? Not bad? All right, do we need to go to the back side? Let's look at a couple there. You got about 15 minutes.
Number 13.
Yeah, go ahead.
I
Phoenix?
don't know if up on the review and it says like cosine is y, right? On the
Cosine is always x, right? Because it's the adjacent side.
right.
The adjacent side is always my x. Sine, remember what is sine related to in trig? Sine is with y, right? So think of y as up and down. That maybe would be a good way. Cosine's with x. And again, I can go to number 13 too, Phoenix.
Oh no, I'm fine. I just had that.
Right on. Mike, did you have number 8?
8 or 9.
All right, let's do this. Let's do number 8. That'd be a good one. Now, when I graph these, a vector in standard form has it in terms of I and j. So like in this one, it'd be negative 6i minus 2j. And that's my vector v, right?
Can you substitute I and J for X and Y?
You can, I wouldn't, when I say substitute,
Yeah. What, like,
it's the same thing. Yeah, so the negative 6 is my change on my x. Negative 2j is my change on my y, right? So in this one, I would be going where? Negative 6 and down negative 2, right? To where this vector would go straight through on through the third quadrant, right? That's what we're looking at.
I know you draw that line.
Because remember, it's a vector, right? So it has an initial, and then it'll keep going on, right?
Okay.
So we have an initial, and then I guess you could call this our terminal spot, our ending point. Now, if I had 2 here and 6 here, what I could do is I graphed it. That's my first thing. But finding my magnitude means I'm finding the distance of the hypotenuse. Well, question, how could I find the distance of this hypotenuse given only what my x and my y changes on my vector? Yeah, Pythagorean theorem, right? So you could do the square root of a squared plus b squared, or you could set it up like a squared plus b squared equals c squared. You could do that as well. But when I do a squared plus b squared, I'll get 36 plus 4. And again, if you're confused with that, be the square root of negative 6 squared plus the square root plus the square root of negative 2. So that's why we get 36 plus 4, and that's how I get it inside like that. Okay?
What would the answer be?
So it'd be the square root of 40, right? So you could either put it as, if I simplified this, I'd have it as 2 square roots of 10, right? Because this would be 2 times 2 times 2 times 5. Pair of 2's bring to the outside. and then I'm left over with 10, right? So I could have 2 square root of 10. I could do that. Or I could put in my calculator, which would you get then?
I got 6.3.
So you could get 6.3 and get that as well.
So you can like leave it in decimal form.
Yeah, you could do either or. And the way that I did on the review sheet, I kept it as either, and you could keep it as either as well. Okay. Remember too, if you see a vector like this with 2 lines around it, that means our vector, our magnitude of our vector here. Okay. So that's what that refers to. Just be careful. That's something that it's easy to forget. All right. Sweetness. Do I need to do another one, or does that make sense?
That makes a lot more sense. I didn't really understand before. But when you put it in like terms of X and Y, it's easy to just do to left X to down Y.
All we're doing is it's like if I say, hey, Brian, go 6 miles to the west side and 2 miles south. You could say, Coach, I could do a quicker way. Well, if I just go 6.3 miles and I went at my magnitude on this vector straight to that, that'd be a straighter path, right? It'd be a straight
That makes much more
line.
sense. Okay, that's easy.
Okay. What about 10 and 11? Do I need to do one of those?
Can you do number 11?
Yeah, I could do number 11. All right, number 11. Remember, if I have my initial in a terminal and I'm trying to find what it is in terms of I and j, there's a formula for that, right? To find what it is in terms of I and j, we can take whatever this point is and whatever this point is, subtract the x's and subtract the y's to find the difference, to find what it is in terms of I and j, meaning this.
Oh, I did the distance.
It would be x2 minus x1, right? And y2 minus y1. So if I find the difference in terms of y and the difference in terms of x,
It's like slope.
I could set it up in terms of I and j. Very similar to what you would have in a slope. The only difference is you're trying to find it in terms of I and j instead of like when you have the m of an equation, it'd be the y2 minus y1 over x2 minus x1.
But I have a question.
Yes, ma'am.
So, would we use this on both 10 and 11?
You would use it on both. That's correct.
Where does the distance formula come into play?
That distance formula is if I were to give you 2 points and I said, hey, what's the magnitude between these 2 points?
So, distance.
That's distance, right?
The distance is the magnitude.
Correct. If you need the distance formula, I'll give it to you on the test. I don't believe we'll have one like that because it's not on the review, right?
Okay.
I type pretty close to the review, but just for your sake, if I said, here's 2 points, find the distance between, that's how you do distance formula there.
That's right.
Okay?
So I got for the points I got 0, 8.
Okay.
So
Correct. For that,
this is number 10.
X2 minus X1.
He's on.
you're on number 10. Yes, you're right.
So
Number
it'd
10.
be
That's
I
0,
plus
8.
8j.
Let's look and see. Let's look and see here. Okay? So I think it's a little off. That's why I said that. So with our x, what we could do, x2 would be -6 minus our, actually I put it underneath y. Let's do it over here. X2 is -6 minus our x1, which would be 2. So -6 minus 2 would be -8. Okay, so we're going to hold on to that. You said I on a y.
Because that's with the X.
Yeah, because that's our change onto the x, right? -8 is. Now, y2 minus y1 would be 6 minus -5, right?
It is plus 5.
Yep, so it'd be 6 plus 5. So it'd be 11, 11j. So remember in standard form, we have our our x plus our y, right? Or our I plus our j. So that's why in this one it'd be -8i plus 11j. Did you see what you did there?
Y plus.
Oh, I was talking about number 10.
Did you get just 8j?
It was 0 and 8.
It's 0 and
Yeah.
8.
8. Yep, you're
So it'd
exactly
be
right.
What would it be?
8j is what I got because remember the change is on the y. If it's the y, it's up and down, right?
So we
What's
don't need to
related
put
with-
if there's a 0.
You don't have to. You don't have to say 0i plus 8j. You could just say 8j is fine.
So it'd be back there equals 8.
Correct. Correct. Say that again.
On number 10, I did the distance formula and I got 8j for number 10.
Did you square root it or did you do x2 minus x1?
I square rooted it and got 8j.
I have to look at it and see because I'm obviously not there. I think I know what you did, but I want to make sure. Think about it in terms of this. If I go j, right? If I just go AJ, that just means I go up 8, right? Well, what's the distance from me to that 8? I just went up, right? It's 8, right? Because if I just hop 8 feet up, right?
Yeah.
If I grew 8 feet, you'd say, Coach, man, you grew 8 feet, right?
Yeah.
And those of you that are on YouTube, you know that I'm about 6'3". So because of that, what we can do is, because there's no change on the eye, you know it's all, the distance will always be 8. So it's, don't always do that. Got me? That's not always going to be the case.
Okay.
All right? That's not always going to be the case. All right? Questions on that one? All right. 12 and 13, are we good? We're good on 12 and 13? You want me just to set it up real quick? I'll just set it up real quick. Number 13, it says theta is equal to 113 degrees, and my magnitude is 1/2, all right? Hey, I know right now that I've been very liberal with allowing you to do a lot of different things right now. A lot of you kind of have max up, and I've been liberal about that because it's your time. This one right here, I'm gonna caution you on, okay? This is one you probably want to just listen to, just real quick. Even if you just listen, that's fine, okay? All right? JT, you good right here? So question here, 113 degrees would be in what quadrant? Yeah, the second, right? So if I were to put that here, this distance from the start to the finish would be 113 degrees. Now, because of that, I like to do it to where I find what this triangle is. Now, if you listen to Miss Allen's podcast, which again, great, she will end up teaching it by using the 113. That doesn't mean she's wrong. That doesn't mean I'm wrong. There's just a difference there, okay? Just a little bit of a difference. So if I end up subtracting 180 minus 113, what would be this angle here? Yeah, 67 degrees. So I put that in. Now, if the magnitude's 1/2, where does 1/2 go?
1/2.
Yeah, the hypotenuse, right? And you're exactly right. You're head on that track. So because of that, now I'm trying to find it what the opposite and the adjacent side is. Remember, the opposite's linked with sine, whereas the adjacent's linked with cosine. So if I did cosine of 67 equals adjacent over hypotenuse, what's my adjacent? Well, we could just say A, right? We don't know what that is. What's hypotenuse? 1/2. So what would I do to get A by itself?
Whoa, what you do? Cosine 67.
Equals adjacent over hypotenuse, right? Because it's cosine is adjacent over hypotenuse. Because that's going to help me find what the A is, which is in terms of I, right? And the O will be terms of J, okay? I do the same thing with sine. Sine of 67 equals opposite over hypotenuse. This would be 1/2, right? So I'm solving for the O, which will get me what my J is. So how do I get 1/2 out of there? Multiply by 1/2 on both sides? Great question. Because it's 1/2, I'm multiplying by that 1/2 to get it to the other side. Now, if it was 2, right? What are you going to be multiplying by? You'd be multiplying. If the 2 was on the bottom, you'd be multiplying by 2 to get to the other side. But since 1/2 is on the bottom, you have to get rid of it by putting it over there, and going from there. So my sign on here is 0.46, and my I is 0.20. Now, if I put that in here, 0.20 I plus 0.46 J, I'd be partially correct. Why would this be only partially correct? Good, it's negative 0.2. Why do you say that, Alex? Exactly. I include the signs at the end because I know if it goes left, it's going to be negative 0.2, and since it goes up, the J is going to be positive there at 0.46. Okay? Does that make sense? Again, Miss Allen, the way she teaches it, I'll just throw this out there. I don't mean to confuse anybody, but what she does, instead of 67, she'll plug in 113 degrees in for 67. Well, when you do that, it automatically gives you what the sine is. So sometimes that's a little bit easier. So like if I did 1/2 cosine of 113 degrees, what it would give to you is negative 0.20, and that would be what you would put in there. For me, I like to see it. I'm a very visual person. So when I do it, I like to actually see that, okay, this is 67, just so that I'm 100% sure that when I plug in that I'm doing what's right. I know that I'm going to have a negative because I go towards the left, and I know that J is going to be positive because it's going up. That's the way I learn. But again, some of you may do that differently, and that's okay.
Hers works when you're doing sine too.
Both, yes. Yes. So if you did 1/2 sine of 113, it would get you positive 0.46.
Okay.
Okay? The big thing on that one is just be careful. I'll just tell you, be careful. I might do, if you do it her way, that's fine. I might then go back, if you have time, check it with my way to just be sure. Okay? All right. Hey, do this for me. One more thing, and I know that I'm almost done. All right. Real quick. Okay, this is very important. Just listen. Just listen to me. If I asked you this, okay, angle, side angle, what would be the first method you would choose? Law of sine. Very good. What if I said side, side angle? You would do, no, it'd be law of sines, but then what would you have to test for? 0, 1, or 2 triangles, correct? Okay. So I'm going to ask you that question. Also, I'm going to give you a triangle. And what I'll do is I'll say, hey, what type of triangle is this? You'll say side, angle, side. And then I'll ask you the question, all right, which method would you use to solve for this triangle first?
Law of sine for that one.
Side, angle, side would be law of cosines. And again, you'll have this. If you need a picture of this, you have it. But side, angle, side is the one where you're going to use law of cosines first. And then I'll say, hey, what would you do after that? You do the law of sines. And that would be it. You don't have to solve for it, but just answer the questions, all right? Does that make sense?
Yeah.
So just be sure of that. Does that make sense, Brooke?
Yeah.
Okay.
Do Monday?
Do Monday. Do Monday. Can I shut this down real quick?
Yeah, that's fine.
All right, this is Coach Johnson. Have a fantastic day, and we'll see y'all later. Bye now.